So we know that definitely that we are from different background here. We have university professors, medical doctors, PhD students, master students, and maybe a few undergrads. And also other people from engineering, name it. So everybody is highly welcome. And we can all take benefit depending on the area of our specialization. And there are so much huge benefit actually we can all take along. So that's why today we are looking into taking benefits of machine learning modeling, irrespective of your backgrounds, under our important clarification series with our logo of always let the data speak, so that we can take advantage more benefit from available data set that are always wasting away. But with appropriate use of machine learning based technology, we can be able to really benefit ourselves from our data sets. So for everybody, like I've always said, to encourage us, we need to do something. Let us get our hands dirty with practicing some of the concepts we've covered. For those that are new, you're all very much welcome. You can easily catch up. So by following a watch list guide that has been provided in our chat forum, and we're always welcome to contact us anytime for any specific clarification. So as things are going, we just have to be motivated. That is, the rate at which AI and sisters fields are getting really involved in our day-to-day activities is getting to another level. We say ML is becoming ubiquitous in science, engineering, and beyond. Mention any field, everybody is talking of machine learning, especially artificial intelligence, but especially machine learning. And I think I've actually clarified this point, because even in other areas of machine learning these days, you cannot successfully deploy state-of-the-art technology there without discussing back to machine learning again. For example, you're talking of NLP, natural language processing, which is one of the fields of AI. You can't really do something really great in NLP without recursing back to using machine learning to build NLP models. So you talk of robotics. So this is hardware-based AI. Then you cannot talk of even beneficial or state-of-the-art robotics without talking of machine learning. We need a robotic that can learn and take decision on its own. So this is why machine learning is becoming one of the most popular and most beneficial aspects of artificial intelligence, because other areas of AI also need machine learning to make them become very useful. So, and that is why ML is one of the hottest topics in the industry today. So multidisciplinary research based on machine learning is taking over academics and even industrial R&D, research and development. So several top companies, you see them talking of how they can deploy ML. How can we secure even the ML we are building? That's another topic on its own. So the majority of advertised jobs are linked to ML or AI directly or indirectly. That is the latest. See, a lot of jobs have been, even in academics now, you want your publication to get attention quickly, you try to bring in machine learning, and quickly you see the way the reviewers will change their mind, or the editor, or the editorial team will quickly change their mind to the decision made earlier. Not long ago, just to encourage us, one of our members in this platform contacted me to, I think it's one of the members that maybe rarely talks in the class, but he's been learning and then following all our weekly lectures. Just he contacted me and he sent his recently published paper to me in his own field of specialization. He was highly elated, happy, and then fulfilled. So, and I was also very happy that he's been learning this thing, following the weaker, and he was able to deploy it with the supervisor and his research team. And they were able to publish in almost 5 point something impact factor journal in his own area. So that is to say that what I've been telling us, that every one of us have that potential to benefit from ML, irrespective of our background, which is the topic that we're looking at today, taking benefit of machine learning modeling, irrespective of your background. So I think it's an engineering, maybe it's an engineering specialist, it's one of these top universities. So you'll be able to pick up one or two things together in our weekly classes and an online engagement in our YouTube channels, and he must be able to actually establish himself, getting a paper out in such a very top journal. I believe is a very big feat for him. So still being a student, so the supervisor, I believe, will be very proud of him, and that is just the beginning of a lot of opportunities to come. So, and this is what I've been encouraging each and every one of us to let us partake. We have research group that we've created, and we encourage the leaders of this group to post updates on the platform so that people who are just joining can benefit, get data, practice. You just need to practice with one, and then everything fall in place. You start going from there to more success stories, as has been the case for some of our students who are now well established in the use of machine learning for solving real-life problems in their own areas of specialization. Yeah. So we say that our platform classes and videos should give you the foundation for applying machine learning and developing new ideas, because one of the ideas we've been focusing on and try to propagate is that you don't need to be a programmer before you can use machine learning. Machine learning is for all. And this is becoming, of recent on now, is I noticed becoming even a kind of highly promoted course. MIT started one of their programs not long ago, no coding AI, that people can actually propose, develop AI solution without writing a single code. Just click, drag and drop. This can be made possible, because it's something to be able to visualize a problem and another thing to be able to solve it. Programming is another thing entirely that are not connected with machine learning. So machine learning is different. Programming is another concept. If you know programming, I'm coming back to that, depending on your background. Your computer science background, that's excellent. See, you can try to look at from programming point of view. Even at that, it's not compulsory for you, even if you're a computer science background. So you can make use of any background or any framework to implement your machine learning solutions. Now, so for those who have been following our platform, either using our weekly classes like this, or checking our YouTube channel, and also following up with the WhatsApp platform and the Telegram platform. So where we posted recently the watch list for some of our YouTube channel videos. So we had a guided list that can show you, okay, if you are starting, watch this, after this, you can watch out this. We refer us to that. Hopefully that will also benefit us as team. Something I would like to mention, while we are trying to take benefit of machine learning modeling in solving various interesting problems we might face in our own various backgrounds or area of specialization, we always stress that ethical usage is emphasized, encouraged, promoted, and practiced on our platforms. Because as we know that everything that has a pros also has cons. Yeah, that's the fact. So I say machine learning is incredibly powerful and can have significant unintended, or sometimes intended actually by some people, negative consequences on the society through targeting, excluding, misusing, and whatever we can define it. Of recent, one of the top guy in Google actually resigned, which has been one of the guy on the foremost team of Google promoting AI, developing a lot of AI concepts, resigned because he felt that he's really troubled that AI might get into the wrong hand, the way things are going. He's feeling the guilt. He starts talking against it and also for that stuff. We can read more about him. So this is one of the things actually I mentioned in some of our previous session. I'm also reiterating it. We have to be very careful. For us, I see a lot of positive things we can use it for. Everything that has advantage also has disadvantages, but we encourage us to go on the advantageous side, the positive side of it. This is what we should try to encourage ourselves and benefit ourselves from. On the negative side, it might be tempting by people who promote it, but we should never think of such because there's always consequence for whatever we get involved in. So sooner or later. So that's why we encourage that we should focus, our focus should be on the beneficial aspect while avoiding the negative usage of machine learning or AI technology. So this is what I refer to as ethical AI-based solution. I call it ethical AI-based solutions, and it is what I teach. This is what I encourage my students to do. I promote it, and I practice in our forums and platforms. So in our day-to-day engagement, and I hope also we try to do the same. So as a kind of maybe just refreshing our brain, like I said, after the short, a bit long break. So what is machine learning? As a revision, we said the goal of machine learning is to build a computer system that can adapt and learn from their experience. While we also say that machine learning algorithms discover the relationship between the variables of a system. What are the variables of a system? The input variable, the output variable, and the AD variable. From where? From direct samples of the system. This is where data set comes in. Every day we generate data sets in our company, in our offices, in our schools, universities. This data is always wasting away because we think it's not useful because we cannot understand what the data is saying. Meanwhile, the data is communicating us, but we couldn't understand what the data is saying. But with machine learning, then we can let the data speak to us in a very clear manner. Now, so again, when we say what is machine learning, it's actually automating the automation, which is getting computer to program themselves. In other words, we want computer to do things by themselves rather than we writing the program. So how do we achieve this? We say writing software is the big challenge there. How do you write a software that will command the computer to program themselves? It has been tried in the past under software engineering, but it was never a success. So finally, machine learning came with the solution by saying, instead of thinking of writing software that will command the computer to write another software, let the data do the work for us. This is where we coin the word, let the data speak. If you allow the data to speak to you, you can actually do a lot of wonderful outcome achievements. And it's also depend on the algorithm you are bringing on the table that can make the data to speak more clearly. Now, so this is the traditional programming we all used to before. So you have data, you have program written by someone. This person might not be trusted. It could make mistake. A lot of issues could be associated with it. And I also analyze to us, once you have data and program, then you have the output. But sometimes this program can take years. Even the best of the best in terms of software development like Microsoft, they take several years to release Windows. And after releasing it, they found out that like Windows Vista, that was a disaster. Windows Vista, after the release, they found out that it contained a lot of bugs. They had to make people to migrate to the next release free of charge because the bugs were just too many. This is after spending several years developing that software. That is how challenging it is to develop a software. And that was why the concept of software engineering came up. Software engineering. It's a concept that came out that, no, we need to really come up with something that can make us to be able to build software in a specialized way, just like the engineering field used to build their product, so that make it to be very strong, bug-free, maintainable, and scalability, robustness, and other attributes of good software. So even with the software engineering, yet there's still very challenging stuff when it comes to building programs. So machine learning said, okay, since data is freely available, if you know the output of the data, then the work is done. Just give me the data and the output of that data, then I'm going to give you the program for free automatically. That is where machine learning came up and has been making the big wave, because data set is out there, wasting away. You see, for example, you have data set from your area of specialization, maybe it's in engineering, maybe civil engineering. You want to be able to know the strength of material. In the past, you have some strength of material that you have actually experimented. You know the attribute of the materials, and then you have the strength. Okay, give me the attribute of those materials. You give me the attribute of those materials, like the weights, the tensile strength, and other attributes that you can take off. Then give me the strength of the material finally. So with this X1, X2, and the output Y you are giving me, then we give to the system, a program will be generated, which we call the model. This is the model. A model will be generated for you, which is the outcome of the training. So how is computer able to do that? There's going to be an algorithm here, which we call machine learning algorithms. Like K-nearest neighbor, we've explained, that will guide the computer how to understand the relationship between the input and this output, and be able to, based on that, generate a program, which we call model or hypothesis function. Hypothesis function. So that is the idea of learning from data coming. Then we usually also look into a few definitions and codes. For example, machine learning is a technique by which a computer can learn from data without using a complex set of different rules. And this approach is mainly based on training a model from data set. Once you have your data set, we train a model. The next subsequent data coming, then we can be able to predict and establish. For example, in educational data mining, we try to see in the history of this university, how many students drop out. There are maybe 100, maybe 1,000 students already drop out from the history of that university. Okay, can you get us the data of those dropout students? We get the data set, the course they study, the family background, the age, the kind of, how did they come to school? Is it by drop off by a public transport or by private car? How many siblings? And also of other questions that might have been documented in the university database about this student. Is it off campus or on campus student? We get those data, those kind of information. So X1, X2, X3. Now, why is this student drop out? Okay. We get the same data for other students who did not drop out, because whenever you have a system you want to model, we need both positive and negative class. The negative class is there. The dropout is those people that drop out. The negative, these are those who don't drop out. So we get all these data together, and then we train our model. See, we build a model that can differentiate between students that might drop out and those that did not drop out. So since we have historical data of students that drop out, it becomes very easy to train. We just train with students that drop out and those that didn't drop out, using the same attributes. Once we have the model well tested, validated, then we can deploy it for real-time use in the institutions. It means once we have a new student, then we can put their information into the system and predict, is this student likely going to drop out or not? It means we have an idea ahead. Oh, this student might drop out. When you identify a student that might drop out, you are not wishing the student bad, but actually it gives the university the opportunity to deploy all the arsenal of student advisory committee to follow up with the student, talk to the student one-on-one, try to see what are the challenges that this student is passing through that might necessitate that he might actually drop out finally. That is, it allows us to take preemptive strike towards preventing problem from happening. So once we identify the problem of this student, you try to resolve some of this problem. Every year you do the predictive solution, quickly identify the student. Is he still at the verge of withdrawing? You notice that based on the support you are given, at a point in time, you notice that the student might be out of that particular danger zone. This is what personally called the positive usage of artificial intelligence. We want to prevent societal evil, because a dropout student is going to be a big challenge to his family. It might not be useful to his own family. Forget all the good talk that a lot of people drop out, this and that. An average person drop out might be psychologically depressed. You see, it's not all dropouts that result in good things, as some people want us to believe. We all seal in reality. So can we prevent people from dropping out due to some challenges that could have been fixed if we had a kind of idea of it? So this is just an example of how, based on data, we can actually make positive impact in the community. It could also be at the beginning of a course, we get data from the previous student section that have attended this course, and then we try to predict which student might fail this course. Once we identify them, we direct them to the advisory team to work closely with this student and make sure that we might be able to prevent them from failing the course. Maybe previous students who fail, they are in the habit of absenting from the class, they are in the habit of not sitting for their midterm exam at the appropriate time, and also for other things. We try to see how can we encourage the present student to avoid such pitfalls that their predecessor fell into that made them fail the exam. That's just an example. So now, we let learning is any process by which a system improves performance from experience. And we also made us in the code, very popular code, that machine learning is the next internet. So which means as internet revolutionized the world, the next thing that is expected to revolutionize our system, as it's already doing, is machine learning. And that is why it cannot be ignored. So someone said that ignore it at your own peril or at your own disadvantage. Now, so when we want to build machine learning, we call something machine learning building framework, or what I call recursive machine learning building framework. It is you should know that machine learning model is an iterative process. So you start with data preparation, get your data. Data preparation involves getting your data. After that, we can have feature engineering, where you try to get the feature manipulated, remove some features, add some features, combine multiple features that are similar, and also for that stuff. We have discussed this at length in some of our earlier videos. After that, once your data is ready, we call this under data. We move to the next stage, which is where we will bring in the algorithm to do the modeling. This is where data modeling actually takes place. So here you can see just start with a very simple algorithm first, like KNN, our friend. And then after that, once the model is built, check the performance of the model. Check the performance measure. Is it doing fine? You always have the opportunity to go back. You might need to go back here, either to do parameter optimization, optimize the parameters of the algorithm. If it's not doing fine now, you can make it to do fine by doing parameter optimization. Sometimes you might need to go back after finishing the parameter optimization, yet it's not working fine. You might need to change the algorithm. Try decision tree. Because remember I said, machine learning is not a dogma. That is, machine learning is not a dogma. It can fail. You might use KNN for a data set from maybe a college of education. The same KNN might work for another data set from the university. But sometimes the same KNN might not work for data from the same college of education in another format or another department. In that case, you have to check other algorithm. So no algorithm can be guaranteed to work for you in all situations. So check other, but it's always good for you to start with simple algorithm. Decision tree, KNN. If it gets really tough, a support vector machine might come with you. Get really tough, then you start thinking of combining different algorithms. And then sometimes also you're going back might not just be to this algorithm side, you might need to go back to the feature engineering, play with the features, remove some features. Some features are not good. They're not contributing to this work. They're making it to be very slow and to be less accurate. You might have to remove some features. And sometimes you might need to go back altogether to data preparation. Maybe you have selected the wrong data set. Then in that case, you have to go back to that place. So this is in line with the principle of let the data speak. If you get the wrong data, even the best of algorithm might not be able to save you to get good results. This is very, very important to note when we build machine learning models. So in the different machine learning building blocks, so we have from different opinions and different ideas. This is 6 steps opinion. Here you are expected to conceptualize the machine learning in your organization. Think of your organization, think of where you are working or your interest. Can you contextualize how machine learning can come in there? Can you think of how you can use it? A lot of data are wasting away, but we never think deeply to contextualize, oh, you can actually use it here. That someone did recently and was able to achieve great success there. So think about it, then explore the data and choose the type of algorithm that you want to use. When you successfully contextualize that, okay, machine learning can be used here, then try to explore the data set and choose the algorithm type you want to use. Don't be dogmatic about it, because there's nothing dogmatic about machine learning algorithm. You can read online, oh, this algorithm is the best. If I used to tell people, somebody telling you this is the best algorithm, maybe it's making a big mistake. There's no algorithm that is the best in machine learning. It depends on the data set. Somebody asks you this question, which algorithm is the best? You say it depends on the problem you're solving. A very superior algorithm might actually fail. It's a very simple data set. Why a simple algorithm will pass? So that's why nothing is dogmatic about choosing the type of algorithm. We have to try and see, but start from simple algorithm to more complex algorithm. Then prepare and clean the data. That's another step according to the 6 steps opinion. So split the prepared data set and perform cross-validation. You might need to split the prepared data set and perform cross-validation. So that is divide the data set into 2. So we've described in our maybe previous sections what are the ways to partition data. The holdout method and partitioning using the cross-validation. Usually I recommend to people to use cross-validation on, first of all, if your data is big, divide your data into 2. Divide it to maybe like 70% training and then 30% test. Keep this 30% away. Don't use it for anything training. Don't use it for even parameter optimization. Use this 70% through what we call the n-fold cross-validation. So use n-fold cross-validation on the 70% for the training set. This is meant to be used for training set. So try to use n-fold cross-validation on the 70% of your data for training. For parameter optimization, use that 70%. The 30% here, or it could also be 80 to 20, that's okay. It's up to you. It's also depend on what has been used before. If you are the first one to work on this data set from your organization, okay, you can decide to use 70% or 80% for training, as the case may be. However, if someone already worked on this data set, you are trying to improve upon his work, then it's very important for you to use the same partitioning they have used. Because if you don't use the same partitioning you used earlier, your comparison you are going to do at the end of your experiment might not be valid. This we have also clarified earlier. So once you take your 70% or 80%, make sure during training, during parameter optimization, you are using these 70% or 80%. The testing set kept separate should not be used for your training and should not be used for parameter optimization. This is to avoid the data getting biased in the course of hyperparameter optimization and the training process. So it means the 2 very popular ways of dividing data, we have the holdout method, where you divide into 2, maybe 80%, 20%. And the n-fold cross-validation, They can both be used together. You see? So on the 80%, you can use the n-fold validation for your training and try to get the parameter optimization. Once you are done with your parameter optimization, now use the complete 80% to do the training of your model. Train it with 80% and now use the remaining 20% for testing. See, this is after you are done with the parameter or hyperparameter optimization. This is what we do. Then this is what they call perform the machine learning optimization. This is what we were referring to. This is hyperparameter. There are some hyperparameters that are associated with each algorithm. We have to try to select the best value for it. For example, k nearest neighbor, KNN. One of the very important hyperparameter here is k. How many k? What is the number of neighbor? Should I use 1 neighbor? Should I use 3 neighbor or 5 neighbor? If it is a classification problem that is involving 2 classes, then we need to use odd numbers. But if it is one that actually involves more than 2 classes or 3 classes, we select it accordingly. Now, so once you are done with the machine learning optimization, then you check your result is reasonable, then it is time for you to actually deploy your model, as the case may be. This is when you follow what they say, the 6 steps, in the opinion of 6-step model building step. But know that these steps are not ones at a go. I mean, you can always go back to any level that you feel you need to make a refinement. I need to check something to make it better. Actually, it has to be iterative. It's not a one-time problem-solving idea. So, again, ML model building steps, 10 steps opinion. You see, the same thing in another, a bit different perspectives. So we are going to look into this. Look at it. Consider our timing. So we're going to consider it. And then we want to also look into, if you are a specialist in computer science, what are the areas you need to be focusing on and concentrating when you are dealing with machine learning modeling? What should be your priority? How can you come in? Where can you make your contribution highly felt? And if your background is not computer science, you are from medical, from any other research area, what are the areas you can focus on? So in addition to these 10-step opinions, and then the other ways that I said, especially what are the ways you have to, different angles to solving problem using AI-based solution, depending on, are you from computer background? Are you from different areas totally? So these and others, by the grace of God, we are going to look at in our next week live session, by the grace of God. So we're going to call it a day here. So to be able to give room for question, if there's any, before we finally call it for the day. So once again, thank you very much all for attending, and I wish you all the best. Again, we encourage the team leaders in the research groups to please, our admin help us recently, maybe you can also help repost some of the links to those research groups so that new people can also join. And then if you are new also, try to communicate, send your message across to the admin. So you see the name Dr. Tijani in the group. You can private chat him, give him your number if you want to be added to the Telegram and the WhatsApp group so that you can get our regular updates. And also the research team leaders, you please post updates, especially your links, so that people who might be interested in your areas of interest can possibly join your team. Once again, thank you all, and I wish you all the best.